free audio.
Hi subscribers and viewers, welcome back to my channel. So in this video we are going to talk about 5G. Okay, we are going to talk about the foundations of 5G to its evolution. That's this period. Okay, so this whole video is about 5G. Okay, so as the topic states here, future of 5G, building a unified, more capable 5G air interface for the next decade and beyond. So it's about 5G in this video. So let's proceed. Mobile has made a leap every 10 years. So this is the evolution of 5G from where it started to where it has gotten to. Now, we started with 1G, which was more of analog voice, and this happened in the 1980s. Okay, so this was mobile voice communications, where we could just make calls between mobile phones and nothing more. Then we moved on to 2G, which was which came in 1990s, and this came with digital voice like the DAMPs, the GSM IS95, that's a CDMA. Okay, that is a 2G, and I think it's still in existence in some rural areas. So, and this gave us the capability to have efficient voice to reach billions. Then we moved on to 3G, which is still in existence. This focused on shifts to mobile data, and this happened in the 2000s, and this came with wireless internet and came with some protocols like the CDMA 2000, EV-GO, WCDMA, and HSPA+, and this happened in the 2000s. Then we moved on to 4G, which is closer to 5G. Mobile broadband and emerging expansion came with 4G, and this happened in 2010. So this came with mobile broadband like the LTE Advanced Gigabit LTE. So Internet of Things actually started under 4G, and then we came to the boss itself, which is the 5G. And 5G development came in 2020s. Okay, that is where more industries started involving themselves in 5G technology. Okay, so this came with a unified future-proof platform, and it came with 5G new radio, which is the NR. Okay, so it's still in development. Most nations have not really adopted 5G yet, even though most of these developed countries are still on it, and they are still assessing how beneficial it will be, its effects on the society as well. Okay, so let's move on. The next thing is delivery on the 5G vision, where virtually everyone and everything is intelligently connected. So we have in the diagrams here, we have our fixed wireless access. Okay, this is a device which has been fixed somewhere in the area. So we have 5G devices in factory, in our transportation, communicating with this 5G fixed wireless access points. Okay, we have the public networks for folks with mobile phones or any wireless 5G enabled device to be able to communicate to this access point here. So this could be a park. We have one deployed in somewhere that looks like a stadium. Okay, and we have some for private networks. We have some for extreme broadband, for indoor enterprises. Okay, you can also use it at homes or in office. We have massive Internet of Things. As I said, 5G actually came for Internet of Things to make life easier for us in our daily movements, our daily activities, in our factories and all sort of things. So in this case, it's going to lessen more human activities on most of these devices. Okay, example, if I'm using a 5G enabled vehicle, I wouldn't need a driver. All I'll need is an artificial intelligence connecting to this 5G access point anywhere and be able to communicate to it and then drive me safely to my destination. Okay, that's an example. Let's move on. Now we have the 5G new radio. So they say 5G new radio is a unified, more capable air interface. So this is talking about this 5G new radio, a radio that has 5G capability. Okay, so in this case, we have in the first column here, we have the diverse services. So under the device services, we have enhanced mobile broadband, we have mission critical services like the drone, we have massive Internet of Things. That's under diverse services. Under diverse spectrum, we have high bands, that is above 24 gigahertz, and that is the that comes with the MM wave protocol. We have the mid bands, that is 5 gigahertz to 6 gigahertz. We have the low bands, that is below 1 gigahertz, and this is actually licensed, shared and unlicensed. Okay, so the high band is licensed, the mid band are shared, and the low bands are unlicensed. Under diverse deployments, these are the diagrams you can see. So we have the 5G new radio technology deployed here, and we have a 5G enabled radio access point deployed, which is actually a CPE. Okay, so which communicates to the main 5G new radio, and then we have our mobile and our routers and our artificial intelligence cars communicating with this access points. We have our factories, and then our health sector is also benefiting from 5G. So now some of the advantages with the 5G new radio is it has 10 times decrease in end-to-end latency, it has 10 times experienced throughput, 3 times spectrum efficiency, 100 times traffic capacity, 100 times network efficiency, and then 10 times connection density. That is the advantage that comes with this 5G new radio. If we move on to the next tab, at our left side we can see a kid having access to the internet. Obviously he's either playing a game, watching videos or pictures, watching 4K videos, playing music, and then listening as well. So 5G will address the insatiable demand for mobile broadband. Over 60% growth in mobile data traffic from 2013 to 2024. So these are the period this 5G is actually being targeted. So we have about 131 gigabytes monthly global mobile data traffic in 2024. That is a prediction for this year. So they say in 2024, 95% of mobile data traffic from multimedia creation and consumption. In 2024, 25% of mobile data traffic will be carried by 5G networks. That's 1.3 times more than 4G, 3G, 2G traffic data today. Okay, if we move on, so it says 5G is essential for next generation mobile experiences. It is fiber-like data. It has fiber-like data speeds, low latency for real-time interactivity, more consistent performance, massive capacity for unlimited data. So this pictures actually depicts how 5G will be useful to our daily day-to-day activities. Example with the first picture here, it says mobilizing media and entertainment, rich user-generated content for YouTubers and content creators. Congested environment, so in an environment where we have numerous usage of data, it will be very ideal for such environment, like the stadiums and public areas like the park and stuff. We have high-speed mobility, so even in a car or in a movement, you can still have access to this high-speed 5G internet connectivity. We have connected cloud computing, so anywhere you find yourself, you can always connect to your cloud and then start your cloud computing and all those things. We have immersive experiences, so this is an Internet of Things device, wearable, and then you can actually watch your virtual reality from there. We have connected vehicles, so this vehicle is actually connected to 5G and it doesn't have a driver. It only has an artificial intelligence driver, which is not human but computer, that actually drives you on the way, connected to 5G, and actually leads you safely to your destination. You have the augmented reality. Okay, so still Internet of Things device that is actually wearable and actually tells you details of whatever information you need to seek, and this is actually aided by 5G technology. So 5G is essential, as I've spoken about it already. So let's move on to the next tab. In the next tab, it says 5G will expand the mobile ecosystem to new industries, powering the digital economy. That is about $13.2 trillion in goods and services by 2035. So this is a prediction. Okay, they've actually predict about our usage of 5G technology in our industries, homes, and all other places. We can see some pictures above here which says enabler to the factory of the future. So under we have 5G, new radio private network, dynamic factory reconfigurability, real-time supply chain visibility, ultra reliable low latency with connection. That is it with its usage in the factory. If we come to the automobile, safer autonomous transportation. So per the sensor built into such 5G enabled vehicle, it's able to at a distance sense objects coming close to it, where it will do the needful by stopping for this object to pass. This object could be human or animal. Okay, so that is it with the automobile industry. We have reliable access to remote healthcare. So with your 5G enabled wearable device on you, you're able to have a real-time check of your health status with the help of 5G. If we come to agriculture, we have a precision agriculture. So we have an automated agriculture enabled 5G device on your farms with its other components, and remotely you're able to operate it with no third party help, as in human help, but 5G is actually aiding this. Okay. The next thing is efficient use of energy and utilities. So even in our energy sector, 5G is still useful. If we come to private networks for logistics, enterprises, industrial purposes, 5G is also needed here. If we move on to sustainable smart cities and infrastructure, so this has got to do with deploying smart devices, Internet of Things in our various public spaces like the malls, the parks, in the cities. Okay, and it's aided by 5G. And then we have digitized logistics and retail, where you can actually buy stuff online and sell stuff online with the help of 5G. Okay, so with all this put into factor, is what is actually being projected to give us about $13.2 trillion by 2035. So let's move on to the next tab. Driving the 5G expansion. So this has got to do with the evolution of 5G, where it started and where it has gotten to. So under the 3G, we have the future-proof platform delivering on the 5G vision, continued expansion to new verticals, deployments, use cases, and spectrum. So we have the Real 15, Real 16, 17, 18 plus evolution. Then underneath it, we have the Real 15 commercialization, Real 16 commercialization, Real 17 commercialization. So under 5G, we have the LTE, essential part of 5G spec, 5G platform. 2019 EMBB global smartphone launches, fixed wireless access. 2020 EMBB expansion beyond smartphone, new markets, regions, nationwide coverage, and SA migration. Longer term expansion, industrial, Internet of Things, enterprise, automotive network, private networks, and licensed spectrum. And this is a period from 2018 all the way to 2030, 2023 plus. This new tab, we have comparison of year one announcements. So under 5G, 4 operators launched, 3 OEMs launched. Under 5G, we have 40 plus operators launching, 40 plus OEMs launching. So under this picture, we can clearly see the number of countries that are actually into 5G deployments. Okay, and even under 5G deployment, we have the sub 6 and sub 6 plus wave, and which is launched or is scheduled to launch. So under the sub 6, we have countries like United Kingdom, and we have telcos like EE, Vodafone UK 302 deploying them in United Kingdom. In Ireland, we have Vodafone IE EIR deploying this technology in Ireland. In Switzerland, we have Sunrise and Swisscom deploying such technology. Under Spain, we have Vodafone ES deploying such technology. Under Monaco, we have Monaco Telecom deploying the sub 6 5G. Under Romania, we have Vodafone, RCS and RDS Orange deploying such technology. Under Finland, we have Elisa and Telia deploying such technology in Finland. Under Germany, we have Deutsche Telekom, Vodafone Germany deploying sub 6 5G technology. Under Kuwait, we have Viva, Orido, Zain deploying such technology. Under Bahrain, we have Batelco Viva deploying. Under Qatar we have Ooredoo, we have Vodafone deploying. Under United Arab Emirates we have Etisalat DU deploying such technology. Under South Africa we have Rain deploying such technology. Under Saudi Arabia we have STC and Zain deploying. And Australia we have Telstra Optus deploying such technology. And the Philippines we have Globe deploying such technologies. Under China we have China Mobile, China Unicom, China Telecom deploying such technologies. And the Philippines we have Globe deploying such technology. Now if we come to SAP 6 Plus mmWave, which is launched or scheduled to be launched, we have in North America we have Verizon, AT&T, Sprint, T-Mobile deploying such technology. Under Italy we have Team, Vodafone Italy deploying such technology. Under Russia we have Megaphone, MTS, Tele2 deploying such technology. Under South Korea we have LGU Plus, we have KT, we have SKT. Under Japan we have KGDI, NTT, Docomo and SoftBank deploying such technologies. Okay, so in all we have only few countries deploying SAP 6 Plus mmWave 5G technology, which are about 1, 2, 3, 4, 5. We have 5 countries deploying such technology. And under 5G 6 SAP we have about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 deploying such technologies. Now let's move on to the next tab. So under this tab we have about 230 plus 5G devices launched or in development, and such brands of 5G smartphones example are Lenovo, LG, Motorola, Nubia, Oneplus, Oppo, Samsung Galaxy, Samsung Galaxy Fold, Samsung Galaxy Note 10 Plus, Samsung A90, Vivo IQ00, Vivo Nex, Xiaomi Mi Mix, Xiaomi Mi Mix Alpha, Xiaomi 9 Pro 5G, ZTE Axon 10 Pro 5G. Okay, so these are mobile phones that has been launched or in development. Under the hotspots and CPEs of 5G we have the ASCII, HTC, Netgear, WNC, Inseego, Netcom, Nokia and ZTE. Okay, so if we come to 5G modules we have the Compal, Fibercom, Longsang, Quectel, Sierra Wireless, Simcom and Telit. So these are devices that has either been launched or under development, and these are 5G enabled devices. Our LTE advancements are essential to 5G, providing ubiquitous coverage and essential services that complement 5G new radio. So we have gigabit LTE is here now and delivers a virtually seamless 5G mobile experiences. Okay, so gigabit LTE, take that in note. And we have the LTE Internet of Things. We have private LTE network. We have CV2X are enabling new mobile use cases today. We have LTE Advanced Pro leadership is essential to success in the 5G era. So we can actually see certain diagrams depicting 5G enabled devices communicating to each other. We have drone communications, which is a 5G enabled drone. We have the existing LTE deployment, which you can communicate with gigabit LTE enabled 5G devices, wearable. We have the voice LTE, which is communication through 5G enabled access points. We have the LTE Internet of Things at homes or offices. We have the 5G enabled automobile vehicle. We have the 5G new radio deployed here. We have CPs deployed around this building. So under here we have new 5G NR wave, which is 10 times gigabit 5G. New 5G NR sub 6 gigahertz and LTE coverage, that is NX1 gigabit 5G. And we have the ubiquitous LTE, which is gigabit LTE, voice LTE. Okay, so it can also be deployed in digital broadcast, in public safety emergency services, that's our health systems, in stadiums, even in surveillance, and in factories as well. So it's 5G new radio design technologies. Okay, so it says our technology inventions drove 5G Rail 15 specifications, early R&D investments, cutting-edge prototypes, fundamental contributions to 3GPP. So under flexible slot-based framework, we have this diagram depicting how flexible slot-based framework actually works, and then the scalable Ofdm numerology. Okay, so under it has low latency, URLLC, forward compatibility. These things you can actually search online and have a better understanding of it. Okay, we have the scalable Ofdm based air interface, and we have self-contained slot structure, and this picture here actually talks about what it is in here. And so it addresses diverse services spectrum and deployments. That is the job of the scalable FDM based air interface and self-contained slot structure. We have advanced channel coding and multi-edge LDPC and CRC aided polar. And we have support large data blocks, reliable control channel. We have massive MIMO, which is been this type of technology is replicated in most RF radios, today's RF radios. So it has massive MIMO, reciprocity based MU MIMO. So it explains that large number of antennas to increase coverage and capacity. So in 5G, it means you are going to deploy more antennas because of the distance it actually communicates. We have mobile wave, beam forming and beam tracking for extreme capacity and throughput. Okay, so this is inventions that drove 5G Rail 15 specifications. Okay, then we have the scalable Ofdm based 5G new radio air interface. So this picture actually talks about the Ofdm based 5G new radio air interface. So this picture talks about the frequency and the time, and further this says 3GPP Rail 15 specifications aligned with Qualcomm research white paper published November 2015. So this was published in 2015, and it's actually talking about the scalable Ofdm based 5G new radio air interface. So this is a technology being built in this 5G device. So as we said earlier, scalable numerology. So 2N scaling of sub-carrier spacing to efficiently support wider bandwidth. So it says frequency localization. Windowing can effectively minimize in-band and out-of-band emissions. So under lower consumption tab, we have single carrier Ofdm utilized for efficient uplink transmissions. So single carrier, okay. So we have asynchronous multiple access can coexist with optimized waveforms and multiple access for Internet of Things (UA). So that is it with this. If we move on to scalable 5G NR Ofdm numerology examples, efficiently address 5G diverse spectrum deployment and services. Scaling reduces FFT processing complexity for wider bandwidth usable hardware. So we have things like outdoor macro coverage, and direct we have the sub-carrier spacing. These are more technical stuffs. We have 2N scaling of sub-carrier spacing, okay, and direct we can see the carrier bandwidth, example 1, 5, 10 and 20 megahertz. Under the outdoor macro and small cell, that is example TDD, that's 3 to 5 gigahertz. We have sub-carrier spacing, example 30 kilohertz. Okay, so these are the carrier bandwidth, and this are example. The example is 100 megahertz. The indoor wideband, example unlicensed 6 gigahertz. So this is a radio which has an unlicensed frequency, which is actually free to use, and it's actually being used indoor. So this has got to do with our Internet of Things and our mobile devices, stuff like that. So sub-carrier spacing, example 60 kilohertz, and we have the carrier bandwidth, which example 160 megahertz. And then we move on to the MM wave, example TDD 28 gigahertz, and we have our carrier spacing, example 120 kilohertz, and the carrier bandwidth is 400 megahertz. So it says it efficiently addresses 5G diverse spectrum deployments and services. So that is it with this type of 5G technology. Okay, now in this tab we have the global snapshot of all allocated or targeted 5G spectrum. 5G is being designed for diverse spectrum types and bands. So we have under the new 5G band, we have the licensed, unlicensed or shared, and the existing band. Okay, so as we can see here, we have countries like the US, Canada, European Union, Britain, Germany, France, Italy, China, Japan, Korea, Japan, India and Australia deploying such technologies. Okay, so in all we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 countries deploying such technologies in their jurisdictions. So as you can see, we can see all the frequencies here and its corresponding components. Okay, let's move on. So expanding 5G with the flexible slot-based framework. These are more technical stuff in here. So it says scalable slot duration, efficient multiplexing of diverse latency and quality of service requirements. We have the broadcast NTV, the cellular V2X network side, integrated access and backhaul, unknown service not yet defined actually. Okay, so this, if you watch this pointers, it points to these various components that comes with this 5G slot based framework. Okay, so we have the enhanced mobile broadband, side link. Example for flooding, we have the dynamic spectrum sharing. Okay, we have the wide area mission critical this side, and we have the light, NR light, new radio light, which is deployed at this framework. So it says self-contained slot structure, ability to independently decode slots and avoid static timing relationships across slots. And then we have the nominal traffic puncturing to enable URLCC transmissions to occur at any time using mini slots. And scalable 5G new radio slot duration for diverse latency or quality of service. So these are certain components we can also see under this scalable 5G new radio slot duration for diverse latency. So it says 14 Ofdm symbols per slot with mini slots. That's 2, 4 or 7 symbols for shorter transmissions. The other tab says supports slot aggregation for data heavy transmissions. The other says efficient multiplexing of long and short transmissions. So these are examples of 5G NR slot structures. Okay. So we have the TDD self-contained opportunity for ULDL scheduling, data and ACK/SRS in the same slot. So slot-based scheduling or control interval. These are more technical stuff, okay, and the 5G technology. And as you can see under D, delete, is it delete control or DL control? We have the DL data guide and UL control. We are under UL, we have the DL control guide, UL data and UL control. So these are some of the components that fall under flexible 5G NR slot structures. If we move on, benefits of the 5G new radio TDD self-contained slot: much faster, more flexible TDD switching and turn around than 4G LTE. So flexibility for additional headers. Example, channel reservation header for alliances shared spectrum. More adaptive ULDL. That's faster TDD switching allows for more flexible capacity allocation. So under it we have these components. Okay, and then we can see its subcomponent, which is low latency, faster TDD turnaround with opportunity for ULDL scheduling, data and ACK in same slot. And under SRS we have efficient massive MIMO, optimized TDD channel reciprocity with opportunity for SRS every slot. Okay, so if we come to the next tab, which is 5G new radio TDD self-contained slot structure in action. 3 examples showcasing faster TDD switching for low latency. Okay, so we have the indoor, outdoor and outdoor wave. Under the indoor, which is sub-6 or wave, we have shorter guide for indoor deployment, fast turnaround DL/UL switch per slot, ultra low latency possible on every slot, maximum flexibility for UL or DL allocation. Under outdoor, we have the sub 6 or wave, that is larger guard for outdoor deployments. DL UL switch per 1 minute per second, that's 5 times faster than LTE. Slot 1 opportunity for ultra low latency, and then bulk of UL traffic goes on slot 3. Under outdoor wave, we have larger guard for outdoor deployments, 6:2 configuration every 1 minute per second. Slot 3 opportunity for ultra low latency, and bulk of UL traffic goes on slot 6 and 7. And so these are the diagrams that shows how this structure is being deployed. Okay. And then we have the 5G NR flexible FDD slot structure, delivering low latency, extended coverage, and forward capability. So FDD baseline for continuous transmission and extended coverage. So this diagram depicts how these slots are structured. Okay, so under the FDD baseline for continuous transmission and extended coverage, we have the FDD full DL slot, and then FDD full UL slot. And these are diagrams that depicts the structures. Under FDD partial slot for faster DL UL turnaround and efficient half duplex FDD implementation. Under it, we have FDD partial DL slots, FDD partial US slot, and these are the diagrams that explains this structure. Advanced ME LDPC channel coding is more efficient than LTE table code at higher data rates. And this is a diagram that talks about what the statement talks about. So normalized throughput for given clock rate, and this is it. So under high efficiency, we have significant gains over LTE table, particularly for large block sizes suitable for MBB. Under low latency, low complexity, we have easily parallelizable decoder skills to achieve higher throughput at low complexity. Under low latency, we have efficient encoding. Decoding enables shorter transmission time at higher throughput. Okay, so these are the things that explains the advanced ME LDPC channel coding. Okay, we move on. Performance gains of CRC aided polar channel coding led to its adoption across many 5G NR control use cases. Okay, you can always go and search for these keyword terms you are seeing here. Okay, we have the 5G NR CRC aided. This is a CA polar design, so efficient construction based on single cyclic redundancy check. That's the meaning of CRC, cyclic redundancy check, for joint detection and decoding. So its job is for joint detection and decoding. Okay, so we have the control, payload, and then we have the single CRC, that's the cyclic redundancy check concatenation as outer code here. And then moves on to U domain bit mapping. So this is a structure it passes through to its final destination. So after the first one, we have the U domain bit mapping. After U domain bit mapping, we have the polar encoder. into bracket Hurricane kernel. Then we move on to the rate matching and channel bit interleaving. Then finally we have the to modulation mapper. Okay, and on the other tab we have the link level gains of 5G new radio CA polar design versus PC polar, that's low into bracket lower is better. So we have these designs here and the rates that comes with it. Okay, so 5G new radio optimized design for massive MIMO. Key enabler for using higher spectrum bands, example 5 GHz with existing LTE sites. So this diagram talks about something which it says exploit 3D beam forming with up to 256 antenna elements. This is what this 5G new radio is doing here. And we have 5G new radio co-located with existing LTE macro sites. Okay. Accurate and timely channel knowledge essential to realizing full benefits. So in this picture we can see our mobile devices connected to this new 5G new radio, and we have the mitigate UL coverage with 5G NR massive MIMO plus HPUE. Okay, so we have enabled through an advanced 5G NR end-to-end massive MIMO design into bracket network and device. So we have optimized design for TDD reciprocity procedures utilizing UL SRS, enhanced CSIRS2 design and reporting mechanism. We have advanced high spatial resolution codebook supporting up to 256 antennas. And then we have new features such as distributed MIMO and a 5G new radio. So, and the 5G new radio optimized design for TDD reciprocity procedures, 5G new radio slot structure, enhanced ref signals, enable fast accurate feedback. Okay, so it says MIMO rate prediction latency reduced from greater than 10 milliseconds in LTE to 1 milliseconds in 5G new radio. And this design here talks about whatever we are reading on this particular page. Okay, so in this city we have our 5G macro massive MIMO new radio deployed. So 5G new radio massive MIMO increases coverage and capacity, faster, more uniform data rates throughout cell. Okay, so we have 8 deployments here. As you can see, most are our mobile devices and it's connecting to this 5G macro massive MIMO new radio. And so if you watch the design down here, we have the 4x4 MIMO, which has a speed of 52 megabits per second. Okay, that's the median burst rate. And we have under 5G new radio massive MIMO, we have 195 megabits per second, which is 3.8 times higher than the 4x4 MIMO. Under cell edge burst rate, we have 4x4 MIMO, which has 27 megabit per second, and under 5G new radio massive MIMO we have 79 megabits per second, which is 2.9% higher than 4x4 MIMO. So on this part, this is where we end on our first part of talking about 5G technology, and I finally end with this picture we are seeing here, which is Frankfurt simulation. So it's actually a simulation that was done in Frankfurt. A test was done on this 5G technology to ascertain how it will work effectively. Okay, so it says Frankfurt simulation 5G NR sub 6. So the 5G technology that was used in this simulation was a sub 6 gigahertz non-standalone. Okay, so it says industry first simulation of real world performance reveals immense 5G user experience gains over 4G. Of course, the speed and how robust it can work. So as we can see here, we have the median best rate. So under median best rate, we have the 4G device in 4G network, which has 56 megabits per second. Under 4G, and then we have 4G device after 5G is deployed, which is 102 megabits per second. And then we have 5G device in 5G network, which has 493 megabits per second. So it says it is way higher. It is 8.8% higher than the ones deployed under 4G device in 4G network, 4G device after 5G is deployed. If we move on to the cell edge best rate, we have 4G device in 4G network, which has 20 megabits per second. We have 4G device after 5G is deployed, which has 39 megabits per second, and we have 5G device in 5G network, which has 184 megabits per second. So which implies that it is 9.2% higher, 9.2 times higher than the ones deployed in 4G device in 4G network, 4G device after 5G is deployed. Okay, and this simulation was actually done in Frankfurt, and this is the results. Alright, thank you very much for watching this video. So this is the part 1 of evolution of the 5G technology. The other parts will be made, and I will make sure I upload them for you viewers and my subscribers to watch them and understand how 5G has come all the way to the point we are now. Okay, thank you very much for watching this video. Please like, share and subscribe, but more importantly, hit on the notification button of the subscription.
Free audio library.